We're talking about equations of a circle, or equations of circles. And the first thing to know is that the radius is always on this side of the equation. It's given, if you don't see a squared sign, if you don't see that present in the equation, then it's already been squared. So for example, if it just simply says equals 25, then that means that the radius is actually the square root of 25. And so you're squaring the radius. So if you see a number like 25, that means the radius is actually 5. All right, so that's the first thing. The second thing to know is that H and K represent the center. And since a circle is all points equidistant from a center, that's an all-important set of numbers. It's critical to know that this negative sign here is built into the equation, so to speak, so that you're going to take the H value and put it in with that negative sign, and you're going to take the K value and put it in with that negative sign. So I'll give you an example. Right here it says in number 31 that this 4, that would be the K value, and then there's no value apparently over here with the X, that would be the H value. So let me rewrite this equation for a moment in a different way. Let me write x minus 0 squared plus y minus 4 squared equals 25. All right, so the HK value, the center, is actually 0 and 4, not negative 4. 0 and 4 is the center. So let's find that. 0 is right here on the x-axis, and then I just go up 4. 1, 2, 3, 4, and plot. So this is my center. That's the center of the circle. Now, circles are easy to sketch if you know the radius. So now that I know the center, I just go 5 units away from that center in all directions. Of course, you're like, all directions? Well, don't do that. Just go in 4 directions. How did I know that the radius was 5 and not 25? Because as we said, this is radius squared. So if it's just 25, we're saying that is equal to the radius squared. And so I would actually need to square root this value to get at r. So then r would be the square root of 25, which is 5. Okay, it doesn't make sense. Of course, if you're a good algebra student, you know this must be plus or minus 5, but it doesn't make sense to say that the radius, which is a distance from the center to this circle, would be negative. That doesn't make any sense. So it's positive 5. Okay, so let's plot this. So I go up 1, 2, 3, 4, 5, and I plot here. And then I'm going to do the same thing in the south direction. Okay, I'm going to go down 1, 2, 3, 4, 5. Okay, and then I'm going to do the same thing to the right. 1, 2, 3, 4, 5. And then I'm going to do the same thing to the left. 1, 2, 3, 4, 5. There you go. And then I'm just going to connect those, okay? It doesn't have to be perfect. If you can't draw a perfect circle, you're like me, and that's okay. So let's do it. Let's do it just one more time. Let's look at this one. The HK value for 33. This number is actually x minus a minus 3 squared. And this number is actually y minus a minus 1 squared. And the radius is actually, if they say 20 here, that means that the radius is equal to, the radius squared is equal to 20. That means the square root, I have to square root this value to get at r. So r is actually the square root of 20. All right, so let's plot this HK value. The center would be at negative 3 and negative 1. That's the center. So negative 3 and negative 1 is right here. Okay, and then we're going to have to estimate the square root of 20 in order to plot the circle, or in order to sketch it. So let's get a value for the square root of 20. So let's put that in the calculator. It comes out to about 4.5. So let's do 4.5 in all those directions. 1, 2, 3, 4, and instead of 5, I'm going to do 4.5. 1, 2, 3, 4, and then instead of 5, 4.5. 1, 2, 3, 4 and a half. 1, 2, 3, 4 and a half. And then you just connect those. All right. Now it's time for you to try this one. All right, so try this one on your own. Give it your best shot. All right, now that you've had an opportunity to try that one on your own, let's move on a little bit to one that is going to require a little bit more math. The focus of your EOC is actually coordinate geometry. It's one of the biggest components of your test. So when we are given just endpoints in a diameter, you can see we can probably get at the radius, right? If we know an endpoint and we know the diameter, or rather I should say, if you know the endpoints of the diameter, then you should be able to get at the radius, but you need to know the distance of that, and you also need to know the midpoint. And let me just draw you a quick sketch. So here I have my circle, my center. I don't know what it is, but I have to know it if I want to know the equation. And then I'm going to write these endpoints on this diameter. All right, so let me make this red. Okay, this one, let's call this -16 and -15. I know that this isn't precisely accurate on a graph just yet, but really I'm just working logically. I'm trying to figure out what to do next. So -14, let's call this one up here -14 and 9. All right. So I've got my points, my endpoints marked of my diameter. The diameter does pass through the center. So you can see, or you should know, that the radii, any radius, any point that, or any segment that goes from the radius to the outside of the circle, that is the same length. So in other words, this is actually equal to this. This is a radius, and so is this. So if I find the middle, if I find this midpoint, then I'll find the center. So let's use the midpoint formula. Okay, so midpoint would be x comma y. I'm finding a point, right? And that's equal to the first x coordinate plus the second divided by 2. It's literally the average. And then I'm going to do the first y coordinate and the second y coordinate divided by 2. Again, the average. So let's put those numbers in. So I've got -16 plus a -14 divided by 2. That's going to be my x coordinate, comma. My y coordinate will be -15 plus 9 over 2. All right, so now let's just do some math. -30 over 2 is what this comes out to, and this comes out to -6 over 2. And now I'm just going to compute that final value. This is going to be -15, and this is -3. All right, so I have my center. Here's my center. Beautiful. Now, in order to find, that's great, and I can start my equation. So let's start the equation. X minus a -15, because this is my h value, and this is my k value. So I can put that in here like this, plus y minus a -3 squared equals the radius squared. And so you can see I'm still missing something. I'm missing this, the radius. So how do I find the radius? Well, I'm going to compute it using the distance formula. So the distance of what? Well, it's going to be the distance from the center. That's why I did the midpoint first, because I want to use the center and one of those endpoints. I'm going to use this endpoint. All right, so let me actually just go back and mark this circle up a little bit more for you. And right now, I'm going to find this distance. Let me highlight it in a different color. I'm going to find this distance right here. And I'm going to use this endpoint. Let me do that in black. I'm going to use this endpoint right here, -14 and 9, and I'm going to use my center. So let's do this. Let's make this green. Okay, this center value was -15 and -3. So let's mark this as -15 and -3. Okay, now let's work the distance formula. So the distance equals between those 2 points, the center and that endpoint of the diameter is going to look like this. It's going to be x, the second x term minus the first squared, and you're going to add that to the second y value minus the first, and you're going to square that and add them together. So it's going to look like this. It's going to be negative 15 minus a minus 14. We're going to square that. We're going to add that to 3 minus 9. And we're going to square that. So this comes out to actually negative 1. And we'll square that. And this comes out to negative 12. But remember, there's still a radical over the top. All right, so this is distance equals distance equals. All right, so let's do this last little bit of math. So this is 1, because negative 1 squared is 1, plus 12 squared, negative 12 squared is 144. So I actually have the distance is equal to the square root of 145. Now that's the distance from the center to that endpoint of the diameter, which the key here is this my radius? It's not my radius, because, or rather, it's not the number that, it is the radius, it's not the number I'm going to put at the end of my equation, though, right? I'm going to put in, it's r squared. So what is 145, the square root of that, squared? That's just 145. All right, that's what I'm going to put at the end. And then I'm also going to change these signs to be x plus 15 squared and y plus 3 squared. All right, so there's my finished equation right here.